We have finally made it to the end of another unit, so now we're going to take a second to go back over everything we've talked about in our probability unit. So to start with, we want to find the probability of something. Remember, it's always that fraction. What you want goes on top, and the total number of outcomes goes on the bottom. So for example, if you are trying to get a heart out of a deck of cards, well, there are 13 hearts in your deck of cards, so 13 out of 52. Remember, your probability can be written as a decimal or a percent or a fraction. If you're going to do a fraction, go ahead and simplify. So this 13 out of 52 would simplify to 1 over 4. Your calculator can do that for you. Type it in, get your decimal, press the math button, and then enter. And it'll transform it into a simplified fraction for you. All right, your decimal and your percent, remember, nothing will ever be over 100% or over 1. So your decimal, your percent, or your fractions always got to be less than 1. We won't ever have any negatives. And you've got to memorize your deck of cards. That's one thing that you just got to have memorized. So when we're looking at a deck of cards, we have 52 total. All right, so if I break that down, we've got two colors, red and black. So that's half and half. And then each red card, you have two suits, right? So you got the hearts and you got the diamonds, those are the reds, and you got the black, which would be the spades and your clubs. Attempt to draw clubs. And then each suit has an ace, and then a 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then what we call face cards, which are jack, queen, and king. Alright, so every suit has ace through king, and then we have the 4 suits, we have the 2 colors, and 52 total cards. So that's something you just have to have memorized for your test. Then we went into talking about Venn diagrams. Remember, Venn diagrams are your circles. So we have 2 and 3 circle ones. But if we're looking at a 2 circle, alright, we'll look at A and B. We put a box around it. Remember, up top, you write your total outside the box. Inside, if you are in the A circle but not B, that's A only. Same thing over here, B only, and then in the middle is the both. On the outside is your neither, so it's the ones that aren't in any of the circles. And then when you add up all of those numbers, you should get your grand total. Same thing applies when you have 3 circles, but then you've got all 3, and then this is a both, this is both, this is both, and then this is the circle as a whole. Independent versus dependent. Keep in mind, this is when you have multiple events taking place. So you are picking a card and then you're picking another card. Or you're rolling a die, picking it up, and you're rolling again. Or you're rolling a die and flipping a coin. But you're doing more than one thing. If it says with replacement, that means that you're putting it back in there every time you're starting from scratch. So that's independent. Rolling a die and flipping a coin will always be independent because you start from scratch each time. Whenever you have independent events, the probability of A and B happening, remember our N, steak and shake, and, equals the probability of A times the probability of B. You just multiply. If it's without replacement, so you take a card out and you leave it out when you draw again, that's going to change the probability, and that's where it's dependent. You're still multiplying, so the probability of A and B happening is the probability of the first one, but then when we multiply, we have to change the outcomes. So then it becomes the probability of B given that A's already happened. Right? So that's like getting a king, then another king without replacement. To get the first king, it's 4 out of 52, but then I leave that king out, so I've only got 3 left out of 51 total. Right? That's our dependent scenario. Independent, if I was getting 2 kings, would be the same. It'd be 4 out of 52, then I put that king back in there, so I still have 4 to choose from out of the total 52. Then we looked at mutually exclusive and non-mutually exclusive. Okay, now before independent, dependent, we were doing more than one event. So we were drawing 2 different cards, or we were rolling a die twice. Now we're looking at one event taking place. So we're picking one card, or we're rolling a die one time. Right? And if you cannot do both at the same time, it's mutually exclusive. If you can, if you have a both, you have an and, then it's not. Right? So for example, for mutually exclusive, drawing a king and a 5. You cannot get a king and a 5 in one draw. So all we do is we add. So we would say 4 out of 52 plus 4 out of 52, and that's 8 out of 52, which we can simplify to 2 out of 13. Right? Keep your denominators big so that you don't have to worry about finding your common denominators. They're already going to be the same. Our formula written out is the probability of A or B, so I want either a king or a 5. It's just A plus B. Just add them together. That's it. If you can do both at the same time, so if we were going to do a black card and a 10, I have two black cards that are 10s. I have the 10 of spades, the 10 of clubs, so I can get both a black card and a 10 at the same time. That's why they're non-mutually exclusive. So my formula for non-mutually exclusive is A or B equals the probability of A plus the probability of B. But if I add those together, I counted those two 10s, those two black 10s, in A and in B. So I counted them twice. So we got to take one out. So I'm going to subtract the probability of both. So if you can get both, you have to take it out. So the probability to get a black card is 26 out of 52, half of them. Get a 10, there's 4 10s. And then to get a black 10, we got those two, the black of spades, the black of clubs. So 26 plus 4 is 30, minus 2 is 28. And then that simplifies to 7 out of 13. So if you can get both at the same time, they're non-mutually exclusive, and you have to subtract one of those overlaps because you don't want to count it twice. Then we looked at two-way tables. Right? So two-way tables is when you have a table that's got two different types of categories going two different ways. So one of the examples that we looked at was if you have an MP3 player and then if you have a cell phone. So one way we put cell phone and then no cell phone, MP3 player, and then no MP3 player. One thing you have to make sure your table has is the totals. You need to have a total column and a total row. That number in the bottom is our grand total. That's the total number of people that are involved in that survey. So I'm just going to put some random numbers in here, and we'll finish the rest. So 5 plus 11 is 16. So the total number of cell phone people is 16. 9 plus 14 is 23, so the total number of people without a cell phone is 23. Total number of MP3 players is 5 plus 9, 14. And the total number of people without an MP3 player is 11 plus 14, which is 25. Then to find my grand total, I'm just going to add. So you can do 16 plus 23 or 14 plus 25, and we get 39 either way. Then you have to answer questions about it. Right? So remember, you find probability is what you want over the total. So the probability that someone has a cell phone is going to be the 16 total people with a cell phone over the 39 total people in the survey. Right? So that's the probability that they have a cell phone. Then you have questions like, given that they don't have an MP3 player, right? So given that they don't have an MP3, what's the chances that they have a cell phone? Right? Well, given no MP3 means I've narrowed it down to this row, the no MP3 players. And then out of that row, we've got 11 with a cell phone. So it becomes 11 over the 25 without MP3 players. Okay, we also took these tables and transformed them into the frequency tables, which is what the percentages. So to do that, if I take and recreate this same table, you've got MP3, no MP3 total, cell phone, no cell phone total. Your total is always going to be 100%, or as a decimal 1.00. That's not something that they're going to tell you, but you know that you can fill that in because we can't have more than 100%. Then to find the rest, we just divide. So we would take that 5 for the cell phone and MP3 players and divide it by the 39 for the total number of people. And we get 0.13. Right? And then we would take the 9 and divide it by the 39 total and get 0.23. Which if we add those together would give us 0.33, and 14 divided by 39 would give us that as well. Sorry, 0.36, not 0.33. And you can fill it in as well. So remember to do your frequency table. You just take each block, divide it by your grand total, and put your decimal or your percent in there. Remember, your grand total will always be 100% in your frequency table. And that's everything we've done with our probability and everything that will be on your test next week.